Hi, this is section P4, which is on rational exponents and radicals. So for the first example, we have the square root of 16. Well, the square root of 16 is going to be positive 4. The reason being, 4 to the second power is 16. The reason why we're raising it to the second power is because the index is blank. Whenever the index is blank, that means it's by default going to be 2. Over here, we have an index of 4. So we're asking ourselves, what number to the fourth power gives us 16? And the answer turns out to be 2. 2 to the fourth power is 16. Therefore, the answer is 2. Over here, we have the same thing. We have index 4. So you're asking yourself, what number to the fourth power is equal to 1 over 16? And it turns out to be 1 over 2 because 1 to the fourth is 1. 2 to the fourth is 16. The next problem says, simplify the expression, assume that x denotes any real number. All right, as you can see, the index is 8 and the exponent is 8. So what we do here is we basically divide. 8 divided by 8 is 1. So it's going to be x to the first power. All right, it says, assume that x denotes any real number. That means x can be positive or it can be negative. In the case when the index is even, as is the case here, we have to put a absolute value around the result. So it's actually absolute value of x. So in the case where x is nth root, the answer would be absolute value of x if n is even. And in the case where n is odd, it's just x. So those are the two cases. In this case, because the index is even, we have to apply the absolute value of x. In the case where n is odd, for example, 7 or 5 or 3 or 1, we would not have to put the absolute value. All right, the next example says, simplify the expression. Assume that a and b denote any real number. So same situation as above. Okay, so what we can do is we can break this up into, instead of writing it as a to the 8th, we know that 7 does not divide into 8 evenly, so we can break it up into a to the 7th times a to the 1st, because 7 and 1 make 8. And we can do the same thing for b. We can have b to the 7th, b to the 2nd. That also makes 9. 7 plus 2 is 9. All right, and now we can pull out these. 7 will come out because 7 is odd. We don't need the absolute value this time. This is going to stay in the radical. This will come out also as a b because 7 divided by 7 is 1. Just like 7 divided by 7 here is also 1. And you're left with these two terms inside. So these two come out, and these two remain. So that is the final answer. All right, let's keep going. All right, here they want us to simplify this expression. We can't combine these because they're not like radicals. What we need to do is we need to break these into them up into factors that are perfect squares. So let's think of factors that are perfect squares of 245 and 125. I'm thinking 25. 25 does go into this. Does 25 go into that is the question. And it does not. So we have to think of a different way to factor 245. I'm just going to use a factor tree. I know that 5 goes into it. Goes into it 49 times. There you go. And 49 is a perfect square. So that's how we want to break it up. 245 will become the square root of 49 times the square root of 5 minus 125. We know that that's 5 times 25. All right, so that's going to be square root of 25 times 5. So this becomes 7, radical 5. This becomes 5, radical 5. And now we have like radicals that we can subtract. 7 take away 5 is 2 radical 5. That is our final answer. All right, these are called rational exponents because they're fractions. So what we do here, we're going to use this fact. A to the 1 over n is the same thing as the nth root of a. All right, so this first one becomes 81 fourth root of 81. So we're asking ourselves, what number to the fourth power gives you 81? Turns out to be 3. Okay, for the next one, this is saying the third root of 64, but there's a negative. Notice that the negative is not in parentheses. Since this is not in parentheses, that means the negative is on the outside of the radical. So that's kind of a tricky thing. So now we ask ourselves, what number to the third power gives us 64? Turns out to be 4. But there's a negative out here, so we have to multiply by negative, which is negative 4 is the final answer. The next one, we have to use a property that says any exponent that is negative can be rewritten as a positive exponent by taking the reciprocal of the expression. So you take the reciprocal of it, and the exponent becomes positive. So in this case, we have 49 to the negative 1/2 is the same thing as 1 over 49 to the positive 1/2. And 1/2 power is the same thing as square root of 49, which is 7. So that would become 1/7 is our final answer. All right, for these, we need to use the property that says a to the m times a to the nth is a to the m plus n. So we're adding these exponents in this case. We have 2/3 plus 1/3 is 3/3, which is 1, which is 5. The next one, we have to use the property that says a to the m divided by a to the nth is a to the m minus n. So in this case, we're subtracting exponents. So we have this. We have 3/5 minus 2/5, which is going to be 3 to the 1/5. All right, so that is our final answer, 3 to the 1/5. All right, the next example. All right, first thing we should do is let's convert that radical into a rational exponent. So the cube root of 6 can be written as 6 to the 1/3. And then you still have that exponent of 3 on the outside. So the inside part is 6 to the 1/3. And then you still have the third power on the outside. So what we do here is we multiply. We're using the property that says a to the m to the nth is equal to a to the m times n. So we multiply these two, which actually cancel each other out. And that's how we get 6 to the first, which is just 6. All right, the next page of notes. So first thing we need to do here is combine the numerators first, which means we have to add because you're multiplying powers that have the same base. So W 8/7 plus 6/7 is going to equal 14/7, which is W squared. All right, actually, let's keep it in terms of a fraction because we still have to subtract the denominator. So now we're going to subtract, we got 14/7, take away 1/7, because when you divide, you subtract. So that's going to leave us with W 13/7. All right, so simplify the expression and eliminate any negative exponents. Assume that all letters denote positive numbers. So That is it. All right, the next problem. First, we should take care of this part. So we multiply. So we still have the a to the 7/4 on the outside. And then here we're going to have 3 to the 3rd, which is 27. And then when you multiply 3 times 3/4, that's 9/4. All over a to the 1/4. So first let's combine these two together. So if you add 7/4 plus 9/4, that's 16/4. And it's because we're adding the exponents, because we're multiplying. So when you add exponents, when you're multiplying powers that have the same base, that means you add the exponents. So that's going to be 16/4 divided by a to the 1/4. And now we're dividing powers, so you subtract. 16 take away 1 is 15/4. So the final answer is going to be 27a to the 15/4. Okay, we got this one. Simplify the expression. For these type of problems, you'd want to convert them using this property. A to the m over n is equal to n. The index is n, and the exponent is m. So this number is your numerator, and this number is your denominator. So if you rewrite these two in rational exponent form, you're going to get y to the 8/9 times y to the 5/6. And of course, in this situation, you're adding the exponents. So let's add the exponents off to the side here. The LCD is going to be 36 times 4 times 4. Actually, it's 18, sorry. 18 is the lowest common denominator, times 2 times 3. That's 16 plus 15 is 31. So that's 31 over 18. So that is going to do it. Y 31 over 18. It says, simplify the expression, express the answer using rational exponents. So this is a rational exponent. So y to the 31 over 18th exponent. All right, the last three problems are rationalizing denominators. So what we need to do is we got to get the radical out of the denominator. So the way you do that is you multiply top and bottom by radical 7 in this case. That's going to give us square root 7 when you multiply the numerators together. And when you multiply the denominators, that's the square root of 49, which is 7. And you cannot cancel those two because this is under a radical and this is not under a radical. So that is our final answer. The goal is to rationalize the denominator, which means get rid of the radical from the denominator. So we've succeeded in doing that. The next problem is pretty much the same. You multiply by the square root of 3 this time. The numerator will be 4 square root of 3. Okay, and the denominator is going to be square root of 9, which gives us 4 square root of 3 over 3. And similar to up above, we're not allowed to cancel those because this is under a square root and this one is not. So that is our final answer, 4 square root 3 over 3. The last problem, we do the same thing. We multiply by square root of 5, square root of 5. We end up with 25 square root of 5 over square root of 25. So we get 25 square root of 5 over 5. The square root of 25 is 5. And now we can simplify these two because these are outside of the radical symbol. So our final answer is 5 square root 5. And that completes this section.